We're going to be looking at number 47. In this particular problem, it takes a deeper dive into the normal model and how things kind of all play out with standard deviations and means and normal CDF and inverse norms. So this is a really great question to work on. If you haven't practiced this one, I want to encourage you to probably pause the video and try this on your own before you just take it and kind of copy the answers or see what I did, because that's not really going to be something that you'll be able to comprehend. You need to try it yourself and kind of get stuck. So to start off with, we have a normal distribution for the younger hens. We know that their average is 50.9, and we know that they lay only 28% of their eggs is an acceptable weight. We know that from the beginning in the problem, they tell us that a desired minimum weight of 54 grams. So that tells me that this value here is 54, and that above 54 is 28%, right? And so what I'd like to do is I'd like to figure out what would the standard deviation for this situation to be. So there's a couple things I'm going to do. The formula that's really going to make this work out is the z-score formula. So z equals the value minus our mean divided by our standard deviation. In this example, we have several of these values, but not all of them, right? So we don't have the z-score. We do have the x value, right? So it's 54, and the mean is 50.9. I also do not have the standard deviation. If I had this, I'd be done with the problem. But so if I can get the z-score, then I can actually find that, plug it back in, and solve for standard deviation. One very cool fact about inverse norm is the fact that we can get the z-score. Inverse norm with using this one key fact. If we know the percentile, and we do know the percentile for this one is down below. This is your 72nd percentile, so we're going to type in 0.72. If you have a newer calculator, you do have the option of choosing the right area, and you're using 28%. But for most people, I think we're stuck using the bigger calculators, so I'm going to kind of just go with that. So I'm using area to the left at 0.72 with a mean of 0 and a standard deviation of 1. Now, why would we be using these two values? These are z-score only. If I use a z-score here, then this is going to give me back the actual z-score, right, for the 0.72. And I needed the z-score because we wanted to do that for the 72nd percentile, because we are looking to find the value for this number here for z-score, so I can plug it in there and solve for our standard deviation here. In this example, my z-score happens to be 0.5828. The book probably doesn't go that into that much detail, but we'll do it. So we know this is equal to 0.5828. So I'm going to take this equation, and I'm going to solve that for sigma. I'll assume that you can do the math on that one, so you just do the subtraction. You can treat that like it's over 1 and do the cross multiplication and work it out that way. Once we do the division, we'll find out that we're going to get our standard deviation is equal to 5.3191. And that's part A. Part B. By the time the hens have reached 1 year, they produce an average of 67 grams. So really, this is the same exact question again. But this time it's for the larger hens once they're full grown. So we have, that's terrible. Okay, that's a little bit better. So we have 67.1. The acceptable weight is still 54 grams. And so I'd like to know, in this question it says, what is the standard deviation for the normal model for the older hens, right? So we know that these hens produce 98% of their eggs are an acceptable weight. So the area down here, the one I'm going to work with, is 2%, because that is the percentile. And the way that we set it up, using the percentile, has to be the area to the left of that, right? And so inverse norm, and I know to do this because I've done the previous question. So I'm just kind of skip to the chase and get to this point, 0, 2, 0, and 1. This is going to give me that z-score for the lower value. The z-score for 2% is negative 2.0537. We knew that was going to be negative because it's a z-score below the mean. And so now I'm going to kind of skip back and use the method I used before. Negative 2.0537 is equal to 54 minus 67.1 divided by the standard deviation. And in the same way, we're going to solve for the standard deviation again. So we get sigma equals, the standard deviation becomes 6.3787. In part C, it asks us, are the egg sizes more consistent for the younger hens or the older hens? You have to remember that consistency or spread answers that are consistently the same, or do I have a large variety of values for these egg weights, is definitely related to spread of a value, since the standard deviation for these smaller hens is 5.3, and the larger hens has a 6.4 standard deviation. Smaller hens have less variation. And this means they're more consistent. If I can spell consistent. Okay, and so that takes me all the way from the beginning of 47 to the end of 47. The important part here is to kind of take it through part A and realize how we figured out that we had a percentage here that would allow us to get the percentile, and that standard deviation is very much focused on this number right here, which allows me to find out exactly how to work through this question to get the standard deviation through using the z-score once we found it from the value in inverse norm. And that takes you all the way through number 47.